Hello everyone. Thank you for joining Nihilent and Microsoft for our webinar. So here we are going to talk about building trust and traceability using blockchain. Quick introduction. My name is Yogesh and I work for Nihilent, a Microsoft Gold partner. I'm going to first spend a couple of quick minutes introducing you to Nihilent and from there on talk about some supply chain scenarios and consumer concerns around the same and how blockchain can help. This will be followed by a deep dive into one such use case, its implementation, challenges and learnings, and also how Microsoft is building an ecosystem to address some of these challenges and how we have seen some of them in action. Who we are? Nihilent is a global consulting and solutions integration company using a holistic and systems approach to problem solving. We have a global presence and operate in Australia from our offices in Sydney and Melbourne. Top right corner shows the services that Nihilent offers. As you could see right at the center, design thinking is core to our service offerings and has been adopted as key method for solving customer problems. Our key focus is to help our customers utilize their data to achieve more for less. Some of our key achievements include setting up of an insurance chain consortium and driving a use case into production and delivering on traceability for an agri supply chain. Most of these implementations have been done on Ethereum, Hyperledger Fabric, and Coda, where most of our capabilities have been built. We're exploring other platforms like Quorum as I speak. We have also implemented some of the large modern data platform projects for BFSI and retail verticals, along with visualizations and analytics solutions. Nihilent is a managed Microsoft Gold partner and 2019 Partner of the Year award winner for Power BI. We take a lot of pride in that. Now coming back to topic of building trust and traceability in supply chains using blockchain. A supply chain network is a network of people and businesses involved in creating and distributing a particular product or service. Typically, a supply chain will involve multiple stakeholders like manufacturers, logistic companies, distributors, retailers, and of course, finally, the consumer. Consumer has a direct influence on what a manufacturer should produce, what material to use, and at what price point. It also, in fact, they also drive product design, procurement, and sourcing practices. Then there are regulators who are ensuring consumer protection. For example, a government may require businesses to disclose detailed information about products, particularly in areas where safety or public health is an issue, such as food. Now, to take you further, that being one of the examples when I come to food, and we will be covering that in much more detail in later slides. Let us now look at some additional scenarios. One such scenario is a forest to fashion supply chain. There is a regulatory requirement and hence a promise from brand to consumer on garment being manufactured is done using a sustainable fiber. But how I as a customer trust that the tag on that garment which says it has used sustainable fiber has actually done that? How does the brand also tackle any adulteration in the fiber, which when it leaves its control and gets into intermediaries? In fact, one of the fiber manufacturers that we were dealing with had some 5,500 intermediaries, and they used to lose control after the fiber has been done and handed over to these intermediaries like spinners, the weavers, the dyers, the gun manufacturers before it actually reaches to us consumers. So there are a lot of challenges there. The next one is around the automobile say supply chain, primarily around auto spare parts. As a consumer, how do I trust that whatever I'm buying is a genuine spare part? Whenever I'm reaching the garages or the shops which sell those auto spare parts, are they genuine ones? And problem is not just for consumer, but also with manufacturer and their businesses. I think, or we think of a scenario wherein a top brand car comes to a standstill due to a spurious spare part. Look at the damage to the brand that does. Another scenario is recall of vehicle itself due to defect identified with one specific faulty component, for example. Am I able to pinpoint to specific automobile, to specific batch, to specific manufacturing facility? That's a major question for even the manufacturing companies. Another very important scenario is with regards to health. We're just looking at a recent article from PharmOut, which points out at WHO report where 10% of drugs in developing nations are counterfeit. Some reports point to be as high as 30%. A staggering 96% of online pharmacies are not even compliant. WHO is concerned that possible 50% of online medications could be fake. And then what about the drugs which are sourced from overseas? Do I have visibility into they being genuine? The counterfeit medicine stats that we were looking at in some surveys and some reports is pretty low. It is less than 1%. But even if that means a life threat to few people, is it not serious? Indeed, it is. So these are some of the supply chains that I wanted to bring up before we deep dive into one such scenario and see how such problems can be solved. Before we deep dive into one such ones, let's go back to the previous discussion around areas where safety to public health is an issue, such as food. Let us look at some of the food recall stats published by foodstandards.gov.au for last 10 years. As you could see, most recalls have been due to undeclared allergens and microbial contaminations. And in fact, even the incorrect labeling itself has been an issue and on the rise. Some additional results to view from a study published around pure and adulterated honey. I'll just give you a moment to look at the same. Now let's move to one specific use case. In slide 5, we went through some of the supply chains around fashion, automobile, and health. One such critical discussion was around areas where safety or public health is an issue, such as food. Now let us pick up this use case and do a bit more deep dive into the food supply chain, the concerns of the consumers, and the regulatory adherence, and how blockchain can be of help to address these concerns. Now, whenever we're talking about such supply chains, there is a concern from the importers of those food items because there are regulatory requirements that needs to be adhered to by the regulators to protect consumers. Some of these are around, has the food being tested in independent approved labs? Can I trust the certificates that are being generated and they have not been tampered with by those independent labs? Has the exporter fulfilled compliance requirements? Do I have enough visibility into the supply chain to be able to trust that information? And it has to be real time, for example. Is the labeling itself correct? We saw some stats where labeling itself is a quite big issue. Is it correct? Where the environmental condition adhered to during the shipping process itself. For example, there are regulations wherein the fruit items being shipped from one country to a specific country needs to be put to a specific temperature, the environmental condition, for minimum 15 days before it reaches the shore, the destination. So do I have visibility on that? Have those conditions been adhered to? These are some of the concerns that would come for the importer, more from the regulator side of it. Then there's a consumer side to it. Consumer is always at the center of it. Is my food safe? If you look at some of these that have been printed, it's of a great concern. The organized crime group trading in adulterated olive oil, or we look at the amount of food frauds in 2018 being reported. In fact, look at this US FDA, where they've seen multi-state outbreak of E. coli illness linked to Romanian lettuce. For example, there was a major concern last year around the leafy vegetables being supplied, and the steps have been taken up by those importers. And the classical meat fraud example. If we look at some of the results or some of the research that has been put together by australasianscience.com.au, it shows that food poisoning results are really very serious when we look at the numbers. The sheer numbers says there have been 5.4 million cases a year of food poisoning, which includes many deaths, and 1.2 million visits to the doctors, and some 300,000 prescriptions for antibiotics, and 2.1 million days of lost work each year. That's pretty serious. And the estimated annual cost of food poisoning in Australia is 1.25 billion. Now let's look at these are some of the concerns from the importer, regulation, and the consumer perspective. Now let's come to blockchain. Now let us try and understand what is this blockchain all about and how can it be of help. Before I go into a few more details, there's some quick facts which are important. You may hear a lot of terms being interchangeably used, hence touching on this subject. First of all, blockchain is not equal to Bitcoin. Bitcoin is only a very specific use case implementation of blockchain for a particular scenario. So it's not blockchain. Second, for understanding perspective, distributed ledger technologies, also referred to as DLT, it's an umbrella term. So DLT can be considered as the umbrella term, and as the name suggests, it's a database of records that isn't stored or confirmed by any one central body. The DLT gives the implementer control over how it is implemented. So coming back to that, what is a blockchain? Blockchain is in fact a form of distributed ledger with a very specific technological underpinning. So blockchain is one kind of DLT. For comparison's sake, Coda is another such implementation of DLT. So I would keep both Coda and blockchain at the same level. And then you can things like platforms like Hyperledger Fabric, Ethereum, and similar ones, they are under the blockchain umbrella, and Bitcoin itself being a blockchain. For us to be on the same page, on the blockchain definition itself, it's a decentralized, transparent ledger with the transaction records, the database that is shared by all network nodes, updated by miners, monitored by everyone, and owned and controlled by no one. Getting into some more details of blockchain, it's a distributed ledger. There are many replicas of the blockchain database. In fact, the more replicas there are, the more authentic it becomes. There are absolutely no intermediaries here. It's near real time, available, configurable. We'll see when we are not going to get into those details of the implementations here, but yeah, we can configure that. Secure, it uses cryptography to create transactions that are impervious to fraud and establishes a shared truth. The database is write once, so it is an immutable record of every transaction that occurs. And one of the most important one is the smart contracts. So this ledger is not only holding the records, the transaction records, but also the business logic itself is stored in the ledger. That means This business logic can actually be used to take actions on the specific information or events as they occur. This brings in pretty good flexibility and efficiency in the system, as we would see. We'll just give you a second to consume that. Next is, what are these value drivers of blockchain? One of them is enhanced transparency. Recording a product's journey through the supply chain helps identify not only its origin, and we're talking about provenance here, which leads to increased trust. Where is that item coming from? But also the touch points through its journey, which could be used by manufacturers to reduce recalls by sharing information with likes of OEMs and regulators. Next is the risk reduction. Blockchain challenges the need to trust counterparties to fulfill obligations, as agreements are codified and executed in a shared immutable environment, providing better security. Traceability and efficiency. The business rules, we just spoke about it in the previous slide, the smart contracts, the business logics, they can be coded to respond to specific events, sometimes even proactively, to take required action, which will not only drive increased efficiency along the supply chain, but also ensure traceability. And then minimize fraud. Blockchain enables asset provenance and full transaction history to be established within a single source of truth. It's fully auditable. That comes built into the technology itself. Now that we have touched upon the use case, specific use case of food traceability, and then what this blockchain is all about, let's get into a bit more of deep dive. How that journey looks like. Any such specific agri product journey would follow this. So there is a key stakeholder there, who's a farmer. Farmers would have their own contracts with the government stating that, okay, this piece of land I'm going to use for growing this particular food item or a fruit, which would be exported to a specific geography, country, or so and so and so. Second, this farmer also gets into a contract with the exporter, wherein the exporter, once they got into a contract, they hand over a checklist to such farmers stating, okay, this is the checklist that needs to be followed, since whatever is being grown on that field or the farmland will be exported to a specific country where there are regulations. And every country has a set of regulations where some countries may have different levels of residue level that can be there on a fruit which is being exported to a specific country or a geography. Now, farmer then gets into a contract, follows a checklist, but this has to be independently vetted, independently checked by labs. So these labs, pre-harvest, they take samples, they do the checks, typically the MRL test and the similar ones, and publish the results back to the exporter. Once they are satisfied with these results, there are certificates, of course, that are generated, and then the harvest happens. The items are shipped to the packaging houses, which does their own quality checks, puts them into punnets, pallets, card boxes, and pushes them into the cold storages. And thereon, it has to be maintained under certain environmental conditions. Say the fruit item being maintained at 2 degrees from here on until it reaches the actual warehouse of the importer. In parallel, of course, there is an operations where the shipping line information or shipping line needs are taken care of, and the transporter arrives with a container. The boxes of these fruits, they're taken out of these packaging houses, cold storages, are then pushed into those containers, which are itself maintained in a particular environmental conditions throughout the journey. at a particular temperature, humidity level, and so on, whatever are those requirements, that gets into a shipping line, reaches the importer. Now, what happens to the importer is, can the importer trust that whatever tests have been done by independent labs, and the certificates that are being produced are the genuine certificates? Do they have even enough visibility of these environmental conditions where they're maintained, not maintained, right? So some of these, or many of these tests are redone on the destination country, which itself means a lot of money spent, typically most of the times billed back to the exporter. And then this is distributed, comes to the supermarkets, and consumers like us, we go and buy those food items. Now, how the experience would change when this entire thing is then put onto a blockchain? As part of this implementation, there's a blockchain layer which is then integrated to an application layer. There's an engine that works between the user interface and the blockchain layer. There's a farmer, as we discussed, the crop details. So these details are then recorded. There's contracts between farmers and the government, the farmer and the exporter around what crop, what needs to be maintained. The independent labs and exporter we discussed, the shipping line itself, and the importer, where this at the destination where these items finally come down to. So all that information is recorded into blockchain, the entire supply chain, as and when at different touch points, right? We will address a problem there in terms of how this information is flowing into the blockchain. There are some challenges and learnings that we have that I'm going to address in a minute. So as part of the supply chain, at different touch points, the information is stored into the blockchain. We have already seen what the various benefits of a blockchain in terms of how data is stored, how it is, we can't erase it, we can't overwrite it. There's an auditability, traceability that is maintained. And then there is an application layer where this entire information can be verified. There are two parties to this verification. One is the importer would like to see the entire traceability till the provenance, where it came from, as well as the consumer like us. So what can be done? One such way of doing it is I can go scan a QR code and then see where this item originated. Who's the farmer? I mean, it depends on the use case to use case, what kind of information you want to display, but you can display absolutely everything from the point of view of who the farmer was, where the land is located, the contracts that farmer is into, the independent labs, the certificates generated by the independent labs, that itself can be stored in the blockchain document chain, right? And other information. So when I have such kind of QR codes as an example printed on those punnets that we buy from the supermarket, it can be scanned and that information can be sought. Now what this brings to the table is, it brings a sort of trust, because we can trust the technology being used, the touch points at which the information is fed, and in fact the importer doesn't even have to wait for this fruit to arrive at the destination. They can in real time see the entire journey in terms of what the contracts the farmer got into, what kind of tests, when they were done, the certificates were uploaded, when did they go to packaging house, when did they leave the packaging house, when did they enter the shipping line, and so on and so forth, right? So that is kind of visibility that it can produce and hence bring in trust. Even if we can reduce these retests being done at the destination by some percentage, that's a big savings, as well as it also addresses various concerns of a consumer. Some of the screens just for your reference. All kind of information. I told you, I mean, it's up to the use case to use case. What information I want to show, the entire journey that I want to show. You can even look at taking a feedback of the entire thing, right? At the user interface, which is This comes in when you scan the QR code, it can just pop up on your mobile phone and can show you all that information that you want to track. The land itself, what was grown, the land details, the quality information, the certificates itself. You can just click on that and download those certificates, which can actually redirect you to the blockchain document library stating that where it is stored, it is genuine or it is not genuine, and so on, and any other further information. So there's a whole lot of information that can be shared depending upon whether you're showing it for the importer, what do you want to show to the end consumer, and so on. That is up to us. Now that we have seen this specific use case in a particular supply chain, food chain, we've seen how blockchain could help. We've also done a bit of a deep dive into how does it look like, the solution itself looks like when it gets onto the blockchain. We looked at the blockchain layer. We looked at various stakeholders in a blockchain. We looked at various touch points where information can go into the blockchain and the application layer. And we also looked at how such information then can be read or accessed by likes of, say, importers or even the authorities and the end consumers like us. Okay. Now coming to some challenges and learnings that we've had during such implementations that we have been doing on the ground, which I would like to really share with yourself. One such challenge is around business adoption. As you saw in such supply chains, there's so many stakeholders in, and onboarding such multiple parties itself is one of the challenges that when you start getting into such implementation. One approach that we have taken is to at least start with few parties to begin with, to start experimenting with it. So even if you can bring 2 or more parties into this, we start recording that information. And then once they start seeing that how this information is really helping in mutually sharing the specific information required without having to expose their core systems, they start to see the value. Issues with existing business processes. So it's just not about the technology or the tech part of it, but the business processes also needs to be aligned to this new way of working. So it's not just about, okay, we'll bring in the blockchain, we'll push this in, we'll start recording the information, and it will all work. No, right? So business processes itself needs to be aligned. Up to date and correct data availability is key. Data is always going to be the key. Governance is another challenge. When we are bringing such kind of supply chains on a blockchain network, we are looking at forming those consortiums, building those consortiums, building those parties, getting those parties on those consortiums, and the administration of such consortiums, and even technologically handling those consortium is definitely a challenge. And I'll just touch upon how Microsoft is looking to solve some of those problems. Quality of data, handling of the disputes. If something goes wrong, how does consortium go to handle it? Who owns the consortium? How the consortium will work? How the various decisions would be taken in the consortium are some of the things that really needs to look at. So there's a whole lot of questions that needs to be answered around that. And of course, the overall discipline of the consortium. Coming to some of the learnings, very important to know, blockchain cannot solve all the problems of the world. So we have to be very careful about which problems should we solve using blockchain. So it's critical that we take a holistic view of the problem in hand and then decide what technology is actually going to work to solve that particular problem. And it may not be blockchain many of the times. So we have to be very careful about that. Data is going to be the key to everything that we do. We know garbage in, garbage out. Even if it's blockchain, the garbage goes in, it's not going to yield the value. Active participation of the consortium members is key to the success. So the consortium management, the governance that we have to set around it is going to be definitely a key for success of such implementations. Automation, automation, and automation. More we can reduce the human intervention, more we'll reduce the mistakes. So M2M communications and reducing human intervention of data inputs is one of the keys. So a temperature reading being recorded from an IoT sensor directly into blockchain ledger is anytime better than a human going, taking the reading and trying to put that into system. It is prone to some sort of mistakes. Now that we have seen these challenges and learnings, just sharing with you what's next. We are looking into upgrading and modernizing of the packaging out infrastructure. As I said, there's a whole lot of changes that needs to be looked at any such implementation in terms of the process change itself and how that infrastructure has to be further built to start doing the capturing the data, doing M2M communication, getting the right data at the right touch points. Integration with shipping line business network is an important one, which has not been done yet. As we know that there have been various POCs done globally for getting the shipping line information. Many of these containers used today, or most of a large portion of these containers used today, have offline loggers. So real-time information is actually not available. So that infrastructure has to be built over a period of time. Or we can tap into such infrastructure which already exists. And then explore and pilot integrations of other business networks. So there could be a banking network, right? We all know there are large insurance business networks that exist, and then there's a supply chain networks. We have seen, and we are working with few of those where insurance business networks are very keen to join the supply chain network to do some marine insurance, for example. And this can further be integrated to bank network for payment integrations. Quickly, Microsoft services and what Microsoft is doing on Azure for us. Microsoft vision for blockchain is to accelerate blockchain deployment for the enterprises, help rapidly deploy end-to-end solutions, providing integration capabilities, and help rapidly deploy blockchain infrastructure on the Azure platform itself. I mentioned it earlier, they're agnostic to the ledger. Hence, the focus is to accelerate blockchain deployments. We have been in journey with Microsoft since the beginning when they started with this many years back. We have used and been through that journey, all the accelerators, tools, and solutions that they have brought in. Started all from the ledger templates where we used to have ARM templates, which helped us really to expedite very quickly in terms of infrastructure provisioning for building solutions on blockchain, including the blockchain network setup and so on. Then that journey continued to building a blockchain workbench, a beautiful system, a system in a box. Less than an hour, you can bring the platform up to do quick POCs. Less than an hour, platform is up. We write our smart contracts, UI configuration, and it is up and running. You can test it in real time. Next is your blockchain development kit. It extends the capabilities of blockchain ledgers on Azure. It helps to connect to interfaces, integrating with legacy apps and protocols and deployments. And of course, a lot of accelerators that have been built in. And a very recent launch is Azure Blockchain Service. It's a fully managed ledger offering from Microsoft. It supports Quorum, Coda, Hyperledger Fabric, and in future, of course, it will support more such ledgers. While it is solving the key challenges like deployment, speed, and complexity, infrastructure management, giving enterprise-grade SLAs, one of the core things that we have loved the most is the consortium management that has been introduced, which has made job of running those consortiums I was talking about in the challenges section much easier, and it's going to get better. Very quick view of the blockchain workbench architecture. I'll just give you a few seconds to look at it. This gets built on its own, as I told you, in very quick time. With that, we reach end of the presentation. You can always contact us for more information, and we are happy to get into a conversation about how we can help operationalize blockchain in your business. We will now take up questions. Please use your questions panel for Q&A.